Welcome to Part 4 of Bio-Rad's Risk Calculator training. The Risk Calculator generates a risk assessment report. This series of videos explains the different elements of that report. This video covers the concept of the expected number of unreliable correctable results reported due to the occurrence of an out-of-control condition, which we refer to as ENUC. Let's return to our hypothetical lab from the previous video. Again, each vertical line represents patient testing. The test tubes represent the QC events. A green test tube indicates that the QCs were accepted. During the testing, an out-of-control condition occurs that affects all subsequent results. In this example, the first two QC events subsequent to the out-of-control condition failed to detect it, but the third QC event gave a QC rule rejection, denoted by the red test tube. During the time that the test system was out of control, 3 patient results had measurement errors that exceeded the quality requirement, denoted by the red asterisks. 2 of the unreliable results occurred prior to the last accepted QC, and 1 unreliable result occurred since the last accepted QC. Results produced prior to the last accepted QC are unlikely to ever be changed and can be considered final. In this example, there are 2 final unreliable results. The last video about enough covered this concept. The patient results produced since the last accepted QC are the most recent and should be corrected if there is a problem. In this example, there is 1 unreliable correctable result. The number of unreliable correctable results depends on the QC strategy, test method performance relative to the allowable total error specification, TEA, and the size of the out-of-control condition. The QC strategy is the QC rule, number of QCs evaluated, and number of analyte examinations between QCs, NB. Test method performance is the test method's bias and imprecision. Suppose a lab is using a 1-3S, 2-2S, R-4S rule with 2 QCs every 50 analyte examinations. The bias is 0, the test method's CV is 1.4%, and the TEA is 4.5%. An out-of-control condition resulting in a 2.2% shift upward occurs. In this case, it can be predicted that the expected number of unreliable results produced due to the out-of-control condition since the last accepted QC is 2.25. The predicted ENUC is based on fairly advanced mathematical computations that won't be covered here. Different magnitudes of out-of-control conditions will be associated with different ENUC values, so we need to look at a range of possible out-of-control conditions. Let's plot our current value. The x-axis represents the magnitude of the out-of-control condition. The y-axis represents the ENUC. For an out-of-control condition of 2.2%, the predicted ENUC is 2.25. Let's look at a larger out-of-control condition. With a larger out-of-control condition, say a 4.5% shift upward, we would expect a larger percentage of unreliable results since the last good QC event. As a result, the predicted ENUC is 13.6. Let's plot the ENUC for this out-of-control condition. Let's take a look at a negative out-of-control condition, say an 8.7% shift downwards. In this case, the predicted ENUC is 24.9. Let's plot the ENUC for this out-of-control condition. We could continue to compute and plot the predicted ENUC over a range of possible out-of-control conditions, producing a curve. In this case, the curve shows the expected number of unreliable final results for a lab using a 1-3S, 2-2S, R-4S rule, with 2 QCs every 50 analyte examinations and an allowable total error requirement of 4.5%. One way to characterize the patient risk implications of a QC strategy is to determine the maximum predicted value for ENUC. Note, in general, the maximum value for ENUC is approximately 1/2 the number of analyte examinations between QCs. If the maximum ENUC is acceptable to the lab, then no matter what size of out-of-control condition might occur, the expected number of unreliable correctable results will be tolerable. This ENUC curve appears here on the risk assessment report. We hope you've found this tutorial helpful. Continue your training by viewing Part 5.